Let's find the domain and range of this square root function. So first, let's remember what the graph of y equals the square root of x looks like. We know that we cannot plug negative numbers into the square root function, and we don't get negative numbers out of the square root function. Square root function looks like this. The domain is all the non-negative reals, and the range is also all the non-negative reals. So now let's think about this function as a transformation of y equals root x. X plus 3 under the radical means that there's a shift 3 to the left. And then minus 2 on the outside of the radical means that the graph is shifted down 2. So we can apply this to writing the domain and range of our square root function. That means we're going to have a domain that is -3 to infinity, because we're shifting the domain 3 to the left, and the range is -2 to infinity. Let's take a look at the function y equals 2 over x. So we know that dividing by 0 is not allowed, but we can divide 2 by any other number we want. So the domain of this function is all real numbers except for 0. This slash means except. So when we say, this is called complement notation, so we're saying that this means all reals except the element 0. And similarly, we're going to get out very large numbers as outputs, numbers that are close to 0, numbers that are large in magnitude and negative, numbers that are very small and negative, but we're never going to get an output of 0. So that means that the range is all real numbers except for 0. So now let's take a look at y equals 1 over x squared plus 2. So we know that for all real numbers, x squared is non-negative. We're never going to square a real number input and get a negative number. So that means the denominator, x squared plus 2, is always positive. So we're never going to have 0 in the denominator, which means the domain is all real numbers. We can plug any number we want into this function. Now let's talk about the range. Well, to get the maximum value of this function, we want to make the denominator as small as we can possibly make it. If we plug 0 in, then 2 is in the denominator, and the output is 1/2. That's the biggest output we can possibly get from this function, because if we plug in any number other than 0, the denominator is going to be bigger, and 1 divided by a number bigger than 2 is going to give us an output that is less than 1/2. So we know the largest number we can get is 1/2 when we plug in 0. And now let's think about what happens when we plug in numbers other than 0. Like if we plug in 10, or -10, or 100, or -100, or 1,000,000, or -1,000,000. What's going to happen is the denominator is going to get larger and larger, and as that happens, the ratio 1 over that large number is going to go to 0. So that means that the range is 0 to 1/2. So that's the domain and range. Let's just quickly look at a graph of this function. The graph of the function looks like this. Here's the maximum, and then we can see in either direction, as we plug in larger and larger values for x, we get closer and closer to 0, but we never reach 0.